In this lesson, we're going to multiply radical expressions. Let's begin by multiplying using the distributive property. So we must distribute the radical 3 to both terms. So square root of 3 times 5. When you're multiplying a radical with a whole number, when you write it and you write them together, the whole number should always be on the outside, and then write your radicals. So square root of 3 times 5 equals 5 square root of 3. Okay, next let's distribute the square root of 3 times square root of 30. So we're going to multiply the inside with the inside. Notice that the roots are the same, so we can multiply the inside with the inside. 30 times 3 is going to give me square root of 90. Now at this point you cannot add them because the radicands are not the same, but we can go ahead and simplify the square root of 90. Because it has a perfect square in it. 9 times 10 is 90. So let's go ahead and take the perfect 9 out. Square root of 9 is 3. It goes outside in front, which is going to give you 3 radical 10. And there you have it. You're done. You can't do anything more to it because the radicands are not the same. So you cannot combine them. So be careful. Don't try to combine things that you cannot combine. At that point, just leave it alone. You are done. In this example, we're going to multiply binomials containing radicals using the FOIL method. Recall FOIL stands for first, outer, inner, last. So let's go ahead and begin this method. So first, square root of 2 times square root of 2 equals square root of 4. Outer, the outer terms, square root of 2 times 5 equals 5 square root of 2. The I stands for inner terms, negative 3 times square root of 2 equals negative 3 square root of 2. And now the last terms, negative 3 times positive 5 equals negative 15. Once you have all your terms, it's a good idea to go through each term and see if there are any terms that have the same root and the same radicand. In other words, you're looking for like terms. And we do have that in this example. The middle terms, 5 square root of 2 minus 3 square root of 2. These are like radicands, like radicals. All you have to do is combine the outside and keep the radicand of 2. So that's going to give us 2 radical 2. We can also go ahead and simplify that first term. Square root of 4 is 2. So that's going to leave me with 2 plus 2 radical 2 minus 15. Now we're not done at this point, and I want to point out some of the most common mistakes that I see when students are solving problems involving radicals. The most common mistake here is the urge or the desire to add 2 plus 2 and give an answer of 4 radical 2 minus 15. And that's wrong. You can't combine regular numbers or integers with radicals. Now what we can do, we can combine the first and last term because the first and last terms are integers. They're not radicals. So when I combine a positive 2 with a negative 15, I'm going to get negative 13 plus 2 radical 2. Now another common mistake I see students make is in this particular example, the urge to want to combine negative 13 with positive 2. And you can't do that. Again, you can't combine integers with radicals. You can only combine like radicals with radicals. So at this point, you are done. The answer is negative 13 plus 2 radical 2. Now, you can also rewrite it another way. You can put the negative 13 in the back and read it as 2 radical 2 minus 13. That's fine as well. But just make sure that you don't try to combine a negative 13 with a positive 2, because if you overwork it, then you're going to wind up getting it wrong. But there you have it. Here we have a square of binomial that contains radicals. So if you have a square of binomial, you can either use the square of binomial formula, or you can simply just put them side by side and use the FOIL method. I'm going to go ahead and just put them side by side and use the FOIL method. You should know by now, anytime you have a binomial and you have a little 2 in the upper corner, that means that you have 2 of the very same thing. So all you need to do is just put them side by side each other and then proceed with the FOIL method if you want to use FOIL. So first, multiplying outside with the outside, that would be 4 times 4, which is going to give me 16. Multiply the inside radicals together. Square root of 3 times square root of 3 equals square root of 9. So what we have is 16 square root of 9. Next, our outer terms. So we have 4 square root of 3 times negative 1. Anytime you have an integer by itself, such as this negative 1, you have to multiply it with the outside numbers, never with the radicand. So 4 times negative 1, what I'm going to have on the outside is negative 4 and then radical 3. Now let's proceed with multiplying the inner terms. That's also going to give me negative 4 radical 3. And now lastly, the last terms, negative 1 times negative 1 equals positive 1. And again, as I stated, once you get all your terms, you should go through and see if there are any like terms, which we do. The middle terms are like terms, and then in addition, I can go ahead and simplify that first term because that's a perfect square. The square root of 9 is 3. We're going to bring that 3 outside and multiply it with the 16. So combining the like terms, keep the radicand of radical 3. And we're going to combine the outside, combining a negative 4 with a negative 4 is going to give me a negative 8. Because remember, if the signs are the same, keep the sign and add the numbers. And then I'm going to go ahead and do 16 times 3, which is going to give me the 48. And be careful. Remember, this is that area that you need to be very cautious with. No, you are not going to subtract 48, take away 8. That would be incorrect. You cannot combine integers with radicals, but you can combine the first and the last term, 48 plus the one that's in the back. And that's going to give you 49 minus 8 radical 3. And that's your answer. Don't try to overwork it by subtracting 49, take away 8. If you go any further, you're going to get it wrong. So again, be careful, know when to stop. At this point, we are done with the problem. And now let's multiply conjugates. Recall from chapter 6 in or chapter 5, multiplying polynomials. Whenever you have two of the same in terms of their terms, that the only difference between the two binomials is their sign. In this example, you have x plus 5, x minus 5. So notice both contains an x and a 5. The only difference between these two binomials are their different signs. That's what we call conjugates. Now, conjugates in terms of radicals would be an expression where it contains the same thing in terms of the numbers inside the binomials. The only difference, again, is their sign. So, for example, 5 plus square root of 2, the conjugate of that would be 5 minus square root of 2. When you are multiplying conjugates, remember whether they're whole numbers, integers, radicals, whatever they are, whatever type of terms they are, when you have conjugates, you only need to do the F and the L of the FOIL method. Now, sure, you can do all of the letters, but the bottom line is the O and the I will always cancel out when you have conjugates. And that's why it's only necessary to do the F and the L. So if I do the F, O-I-L, if I do all of the letters, what you're going to see here is, you'll notice, take a look at outer and inner. Outer and inner are opposites of each other, and that is the reason why you only need to do the F and the L. It's just extra pencil work because it's always going to cancel out. So the bottom line is square root of 3 times square root of 3 equals square root of 9. Once we solve the square root of 9, square root of 9 is 3. 3 minus 36, and that last term there in the back. Combine those two together, those two whole integers, and what you have is negative 33, and that's your answer. You're done at that point. So we've multiplied conjugates using the FOIL method, but in this method we only really need to do the F and the L, so keep that in mind when you're multiplying conjugates. Let's multiply another set of conjugates. So we're going to do it the easy, quick method, just multiplying the F and the L. So square root of 6 times square root of 6 equals square root of 36. Last, positive 2 times negative 2 equals negative 4. Let's go ahead and simplify that perfect square. Square root of 36 is 6. 6 take away 4 equals 2. Done. There's your answer. Here we're going to multiply another set of conjugates. All we need to do is do the F and the L. So multiplying first, 2 times 2 equals 4. Last, multiplying the outer, positive 3 times negative 3 is going to give me negative 9 on the outside. Multiplying inside the radicands, 5 times 5 is 25, so you'll have square root of 25. That's a perfect square. Let's go ahead and solve. The square root of 25 is 5. It's going to come outside and multiply with 9 to give you negative 45. So now you have 4 minus 45. When the signs are different, subtract, take the sign from the larger number, and that's going to give us an answer of negative 41. And there you have it.